Hi everyone, what's up? Today I want to show you how you can solve this integral right here. Now it may seem kind of hard because it's like sine to the 7th power, but it's actually relatively easy to solve, okay? I'm going to show you what you can do. So the first thing you want to do is, of course, you want to rewrite this integrand, and I'm going to do that like this. So I'm going to say that this will be equal to the antiderivative of sine x times sine to the 6th power dx. Okay, now this doesn't seem like too big of a change, but there's actually something really nice about sine to the 6th power. So there's a nice trigonometric identity. I'm gonna write it in blue. So hopefully you know this one. 1 will be equal to sine squared x plus cosine squared x. Okay. Now I want to use this identity to approximate, well, I want to say approximate, but really I want to use this identity to have an exact expression for sine to the 6th power, okay? Now that's relatively easy because over here we have sine to sine squared, okay? So I can just simply cube sine squared and then I would get sine to the 6th power, okay? So this is something that you can do. So if you have sine squared and you take the cube of that, well, what is sine squared equal to? Well, we know we can just move cosine squared to the other side. So we're going to get the following. We have 1 minus cosine, and actually I want to do this on this line over here. Let me write that again. We have sine squared x cubed will be equal to 1 minus cosine x cosine squared cubed, okay? So instead of writing sine to the 6th power, I'm going to write 1 minus cosine squared to the 3rd power, okay? Because there's something really nice that we can do with that integrand. So we're going to have sine x times sine to the 6. We know that it's going to be equal to 1 minus cosine squared x to the 3rd power dx, okay? So this is the integral that we get. Now take a really good look at it. Hopefully you see that cosine, that sine is a derivative of cosine, okay? Now that should tell you that we can use substitution for this antiderivative, okay? And that's exactly what I'm gonna do. So I'm gonna say that, semicolon, I'm gonna let u be equal to, that would be cosine x. That way I just simply need to write u squared to get rid of this cosine squared. And that means that if du is equal to cosine x, then minus du will be equal to sine x dx, okay? So remember, cosine gives you a negative in front of its derivative sine x. So you can just simply move this negative to the other side, and you get that sine x times dx will be equal to minus du, okay? So that means that we can rewrite this integral like this. So I'm gonna continue down here. So far we know that the integral of sine to the 7th power dx will be equal to the integral of, so what about this? So we know sine x dx, that's going to be du minus du. So I'm going to move this negative here. So we have negative in front, and then we have 1 minus cosine squared. So 1 minus cosine, turns out that's equal to u. So we have u squared, and now this entire thing will be cubed. And then sine x dx, that's just going to be minus du. We already accounted for the negative, so this is just du, okay? So now, what can you do in this case? Well, I think the easiest thing to do is to just expand this binomial, okay? Hopefully, you remember this formula from probably a couple of years ago from algebra. If you have, I'm gonna write it over here. So if you have two numbers, a and b, and you're adding them up, I'm actually gonna use a negative sign, so we have the explicit formula, because over here we have 1 minus u squared. In this case, u squared would just simply be b, and a would be 1. So if you have a minus b cubed, well, remember, you can just use the binomial theorem to prove this. But remember, this will just be, or just FOIL the three terms, kind of long, but yeah, you can also do that. This will be the same as a cubed minus 3a squared times b plus 3ab squared minus b cubed, okay? So this is how you can expand an expression like this, and I'm gonna use this exact same formula to expand this integrand, okay? So let's see what we get. So we're gonna get that this will be equal to, we have negative in front, and this will be the integral of, so we have 1 would be a, so we have 1 cubed, that's 1. And we have minus 3a squared, that is minus 3 times 1 times b. So this will be minus 3 times u squared. Remember, b is equal to u squared. Now we have plus 3a, that's going to be 3b squared, that is going to be b, that is going to be u to the fourth power, okay? So it is going to be plus 3a, not a, sorry. We just have u in this case. We just have 1 in this case, so not a. This will be 3 to the fourth power. And now we have minus b cubed, that's going to be minus u to the sixth power, okay? And now we just need to integrate this long polynomial and just plug, just undo the substitution we used. So what is this integral equal to? Well, the integral of 1 is going to be u, so we have minus u. Then we're going to have the integral of 3u squared, that's going to be u cubed. We have negative, negative, that's going to be positive. We have u cubed. Now this, the integral of 3u to the fourth power, that's going to be, with the negative, that's going to be minus 3u to the fifth power divided by 5. And now this one's going to be plus u to the seventh power, okay? We have u to 6, you just use the power rule, you get this, and you can't forget about plus c, okay? So now, using this, well, with this expression, you can just simply undo the substitution we use, which is up here. So instead of writing u, we're going to say that. I'm going to write this as a final answer. The integral of sine to the seventh power dx will be equal to, so let's see, we have u to seventh power. This will be equal to cosine to the seventh power x divided by 7 plus, this would be minus, we have minus 3 cosine to the fifth power x divided by 5. Now these two, there's actually something really nice that you can do to simplify these two. This will be minus cosine. Let me show you. This will be minus cosine x plus cosine cubed. Something really nice that you can do there is that you have cosine x times cosine, 1 minus. So it's going to be cosine squared. So this is 1 minus sine squared x. These two terms, minus u plus u to the third power, will be equal to this. So we have minus cosine x plus cosine x times cosine squared, which is what 1 minus sine squared is equal to. So actually, notice that if you distribute this cosine x to this term over here, I'm going to do that, red actually, I haven't used red. So this cosine goes away and this cosine goes away with that -1. And then in the end, you just simply get that this will be equal to, I'm going to expand out the entire thing. So this will just be, well, not expand, this will just be minus cosine x sine square x, okay? So u minus u plus u to the third power can also be simplified as this term right here, okay? Because you distribute cosine x times 1 minus cosine x, that goes away, and you have cosine x times minus sine squared, you get this. So I'm just going to say that this will be equal to minus cosine x sine x plus c, okay? And this is the final answer. Maybe it's not that pretty, it's a really long expression. Lots of cosines, but I mean, we got sine to the seventh power, so we can't really expect anything pretty. But that's the solution. This is a really nice problem. It's really not that hard to solve. I think probably the hardest part is maybe knowing what to do when you get to this step. There may be some other things you can do. You may be able to try trigonometric substitution. However, that may take you back to sine to the seventh power if you happen to choose the exact substitution that undoes all these trigonometric substitutions, that you may end up in sine to seventh power. It may just be easier to just expand, just try to figure out what this binomial cubed is equal to, and then just integrate each term and just get this long, and I actually missed, it's sine squared, okay? Hopefully you noticed that. That's sine squared. So that's the entire solution, okay? So hopefully you enjoyed this video, and see you in the next one. Bye.